Alrighty, good morning, 7th grade. Today should be Wednesday, February 25th. These are the notes that you need to complete with this video. You should be starting on page 473, and we're going to be working on a couple of these activities, and then you're going to have a practice page that goes along with it. So if at any point you need to pause this video to catch up to me, you have that autonomy, you have that freedom to do that. One of the good things about the videos, but I'm going to just kind of keep moving. If you need to pause, and then there might be a couple times where I tell you to pause. So starting on page 473, the getting started activity, first thing it wants to do is consider the equations y equals x and y equals negative x. It wants us to label each equation on the coordinate plane. So if we look at y equals x, well, we know that mx would be our slope, so this would have a positive slope and this would have a negative slope. So our blue line here would be our y equals x, and our red line would be y equals negative x. Okay. Then it wants us to label the point of intersection, which is going to be that middle point right there. And then that third question says, interpret the meaning of the point of intersection. So that point of intersection is where your statement is true. So whenever you're solving for a system of equations, you are looking for that point of intersection. So what we're going to say for number 3 is we're going to label where they intersect, which is the origin, 0, 0. And we're going to say it makes this statement true. Okay, so for a statement to be true, it has to have a point of intersection. That means there is one solution to that system of equations, and we are going to talk about some different things that can happen with a system. Go ahead and look at your next page. Here we have kind of a real-world example of this. So in the red here, it says, many of the diagonal roads in Washington, D.C. have the names of U.S. states. Except for California and Ohio, every state provides the name for an avenue. California is a street and Ohio is a drive. There is also a Puerto Rico avenue. So then at the bottom here, we're asked some questions about the map. So number 1, answer each question and explain your reasoning according to the map shown. Letter A says, is it possible to meet a friend at the intersection of 1st Street and 2nd Street? So if we were to look at those two streets, we have 1st Street and 2nd Street. What do we notice about these two lines? Hopefully you're noticing that they're parallel. They will never, ever, ever intersect. Okay, that means there is no solutions to the system. Okay, so our answer is going to be no, because the streets are parallel. So we are going to learn that whenever you have two parallel lines, there is no solution to that, and it cannot work. Letter B, is it possible to meet a friend at the intersection of Delaware Avenue and Constitution Avenue? So I see Constitution and I see Delaware. Is it possible to meet a friend at the intersection there? Hopefully you're thinking yes. Why? Because they intersect. There is one solution to the system. Okay. Letter C. Is it possible to meet a friend at the intersection of C Street and 2nd Street? I want you to work through this one, pause this video, come back when you've solved it to check your answer. Hopefully you've said the same thing or a similar thing to me. Yes, you can meet there because they intersect. There is one solution. Okay, last one's a little bit different. It says, in how many places can you stand when you are at the intersection of Independence and South B Street? So if we look at Independence Avenue and South B Street, Hopefully you're noticing that they're the same road. So if I were to ask to meet on that street, well, they're the same street. So there's an infinite number of kind of intersections. You could meet at any point on that street. So our answer here is going to be there is an infinite number of intersections. So this will also apply whenever we're looking at systems of equations. We're going to look at the next page, and we're going to be able to apply that. So we are now on page 475. We have a situation up top that we're going to have to make an equation for. So up top it says Jimmy starts. I'm going to do some highlighting. Jimmy starts with $64 in his savings account and saves $25 per week. So that's our rate of change. Eric decides that he wants to save money also. Eric has $25 in his savings account and saves the same amount as Jimmy per week. So they are both saving at a rate of $25 per week. First, it says, write a system of two equations that shows the amount Eric and Jimmy save. Whenever you're writing the system of equations, you're going to want to write it in slope-intercept form. That's just going to be the simplest, in my opinion, to come up with that equation. Okay, so we're going to have Jimmy. And we are going to have Eric. Okay, and whenever you're doing a system of equations, you should technically have this little bracket thing because it shows that these equations are related and they're not just linear equations. Okay, so I'm going to go ahead and make my bracket. I want you to pause the video, come up with your equations for both of them, and then play it once you're ready to check your answer. All right, go ahead and check your answer. Hopefully you got something similar to me. Of course, if you rearranged the 64 and the plus 25x, it would still do the same thing. Next, create a graph of the linear system on the coordinate plane shown. Same deal, go ahead and graph yours. Pause this video, graph yours, and then check your answer with mine when you're done. Alrighty, go ahead and check your graph with mine. One thing you'll notice is that they are parallel, and there's never going to be a point of intersection. So if we look next at number 3, it says, what does the slope of each graph represent in the problem solution? Well, that's their rate of change. So it's in this specific situation, it's representing that they're saving $25 each week. Because they are saving that same rate, we know that Eric is never going to catch up to Jimmy. Okay. Next one, what is the same for both Jimmy and Eric? Their slope is the same and their y-intercept is different. Okay. Number 5, what is the point of intersection for the systems of equations? There will never, ever, 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 ever be a point that these two lines intersect because their rate of change is the same. Okay, so how we represent that means there's no solutions, and how we represent that in like a symbol is that there are 0 solutions. Okay, so that's our symbol, but we're also going to write it in words. We're going to say there is no point of intersection. Okay, so that's our answer for number 5. We're going to look at the next page. We're going to skip number 6 and 7, and we're going to look at Amani's statement. So Amani says, I can verify that the system has no solutions algebraically. And then she goes on to do that. So she takes both equations, she sets them equal to each other, and she solves them. And what you'll see here at the end is she gets that 25 is equal to 64. Well, that's not true. So if you get a statement that isn't true, you just solved algebraically that there's no solution. So the same thing we did with the graph, you can do with algebra. Okay. That's it for that page. Go ahead and look at the next one. And we're going to follow a similar process on this one, just with a new situation. Okay, so in the red here, Eric's sister Trish saved $475 working part-time during the first semester of school. I'm going to highlight some stuff. She recently quit her part-time job to play on the high school's softball team. She withdraws $25 each week, so we're withdrawing it, so that's going to be negative, for her savings account for spending money while she is not working. It says write a system of equations of the amount that Trish and Eric will have in their respective savings account. The phrasing of this one is a little bit confusing. So we've got two people that we're dealing with. We have Eric and we have Trish. We're going to do a little bracket thing. It might look ugly, but we'll practice it. So Eric, they are both saving separately. No. Eric's sister Trish. So Trish saved $475. Okay. Working a part-time job the first semester of school. She recently quit her part-time job to play on the high school's softball team, and she withdraws $25 each week from her savings account for spending money while she's not working. So we have Trish. So we're mainly we have Trish that has that $475 to start, and then we're taking away $25 each week. Eric's equation comes from the previous questions. So Eric's equation will be, oh no, I forgot to do y equals. Back it up. So we're going to have y equals 475 minus 25x. You can also do negative 25x plus 475. And then Eric's equation was y equals 25x plus 25. Okay, so those are those separate equations. All right, so now that we have our equations, we're going to look at number 11, where we have to graph our linear systems on the coordinate plane. So go ahead and graph it. Pause this video, graph, and then come back to check your graph. All right, here are your two lines. If you were to find your point of intersection, it would be about right there. Oop. Which would be approximately at 9, 250 to answer number 12. Okay, then if we were to compare the slopes, we can see that the slope values, one's positive, one's negative, so they're opposite. Number 14, determine the solution of the system algebraically. So whenever you are told to do it algebraically, that's where we would substitute one y for the other. So we're just going to check our work to make sure that it matches. So this is whenever you look up here, you take your y value. It says y equals 25x plus 25, and we're going to take that and we're going to plug it in for our other y and solve for x. Use that to get our y. Go ahead and fully solve this system on your own. Pause this video to fully solve it. I want you to get the coordinates. Once you get the coordinates, you can replay this video to check your work. All right, you can compare your work with mine. Your end coordinate should match what we got from the graph, and that was 9, with x value of 9, y value of 250. So this is how you would find an example whenever you have one solution. Now we're going to look at an example where you're going to have an infinite many solutions. So here it says you have worked with systems of linear equations that have one solution and no solutions. Number 1, describe the graphs in the system of linear equations with one solution. We would have one point of intersection, or we can just say one intersection. Oops. If there is a graph that has no solutions, they would be parallel with no intersection. Now, if we think back to our map in the getting started, we would know that those lines were the exact same, that they were the exact same lines, so they had an infinite number of points. Here's an example of how we can look at that algebraically. So we're given a system of equations right here, and it wants us to plug in x values into each one and to see what we get whenever we plug those in. So I want you to go through to complete this table. So I will give you the first row. So if we were to plug in -2 for x, you would get a y value of 0. And for our second equation, if you were to plug in -2 for x, you would also get 0. Now you're going to have to do more than one because a normal system of equations would have one solution. So go ahead and go through the table, see what you get for the table, and then replay the video to check your work. You can go ahead and compare your table with mine, and you'll notice that you will get the same y value no matter what x value you plug in, showing that there is an infinite number of solutions here. Okay, so we know that they're equivalent. So if we look at letter B, it says, describe the equations that make up the system. What can you conclude about the number of solutions? We're going to say there's an infinite number of solutions, and we're going to say they are equivalent. Okay, let's look at the next page. Here's an example of how we can look at this algebraically. So we are given a system of equations here. We have Arav and Victoria that both took this equations, set them equal to the other, and solved. Notice they get something slightly different, but the point is still the same. They're both correct. They're both getting that 6 is equal to 6, that x is equal to x. Whenever you see something like this, that means that there is an infinite number of solutions. So that's what you can kind of look out for there. Go ahead and look. That's all we're going to look at on that page. Go ahead and look at the next one. We're just, these shouldn't take too long, so we're going to go through both of these. So this one says, Samson and Adrian help set up the booths at the fair. The organizers pay them each $7 per hour to carry the wood needed to build the various booths. Samson arrives at 7 a.m. and begins working immediately. Adrian arrives 90 minutes later and starts working. First, we need to make our system of equations. So first, we can talk about Samson. And then we'll talk about Adrian. Make my little bracket here to show that it's a system. We're going to have y equals, and we're making $7 per hour for both of them. So that's our rate of change. It doesn't tell us how long they're working, so we would say 7 a.m. would be like that starting time, so that would be at our origin, so that would be plus 0. So we're just going to leave it at y equals 7x. And then for Adrian, he's also going to make $7. But he's going to come in an hour and a half later. So that hour and a half is going to affect his hourly pay. So how we can do this is we're going to go into here and we're going to say x minus 1.5. So what this is doing is whenever we were to distribute, we would distribute, okay, we're doing our 7 times our hour, but we're also we're going to be making less because it's an hour and a half less. So this would be our system of equations here that we would then be able to use to solve both just by observing and then also algebraically. So if we were to look first to analyze just based off observation, if we look at both of these equations, if we were to distribute this one out, we would have 7x as our slope. So we can see that our slopes are going to be the same. We also know that because this one has a y-intercept of a negative 1.5 and this one's y-intercept is 0, they're not going to be on the same line. So we know they have the same slope, but we know they are not on the same line. So that's going to mean that they're going to run parallel to each other and that we're going to have no solutions. So we need to say for number 2 that the slopes are the same. There's no solution. Okay, and it's great that we can tell that by looking at the problem, but we also need to be able to check our work algebraically to make sure that our work is truthful. So we're going to do that. We're going to do that substitution method. So you're going to take here that you have your y equals 7x, and you're going to plug that y into here, and we're going to solve for our x. Go ahead and just solve for your x. You're going to see something that's a little weird. Once you've gotten to that weird part, go ahead and hit play and we'll walk through it. All right, you're going to get something like 0 equals negative 10.5. And I got that because at this step, I had to subtract 7x from this side. And if you do 7x minus 7x, you're going to get 0. So you have 0 equals negative 10.5. And that is not true. So that tells us that there's no solution. It doesn't make sense. So we know there's no solution. So you can say that that's your simple for that. Okay, our result there is false. Last page, and then I'll send you off to do some practice on your own. So here we have another situation. It says on Monday night, the fair runs a special for local schools. When you purchase tickets from the school, you can buy student tickets for $4 and adult tickets for $4. You can buy 5 tickets and spend $20. Okay, so if we were to label variables to these, we have student tickets and we have adult tickets. So we're going to call, let's do x equals student tickets. And we'll say y equals adult tickets. Okay, so now our first equation, we're going to use the actual money. Okay, so it says we can buy 4 tickets of student tickets. We can buy $4 worth of adult tickets. Up to 5, and we're going to spend $20. How we can represent this is our AX plus BY equals C. So we would have $4, so 4 would be our X, so 4X. Okay, because you're buying $4 worth of student tickets. Then you're buying $4 worth of adult tickets, and that's going to equal your C, which is going to be $20. Okay, I forgot my little bracket. Our other equation that we can make based off this is just with the number of tickets to equal that 5 tickets. So we've made an equation that has the money amount, but we haven't made an equation that has this 5 tickets. Okay, so you can buy up to 5 tickets, and you can buy any assortment of that. So our equation for that is going to be x plus y equals 5. Okay, any variation of x plus y equals 5 would work there. So then, if we analyze them, to be able to analyze them, we need to have them both in that slope-intercept form. So if we were to take that first one, we would have 4y equals negative 4x plus 20. We'd have to divide. I'm just trying to get this in the slope-intercept form. We would have y equals negative x, because negative 4 divided by 4, you're left with just negative 1. And then 20 divided by 4 would be 5. Okay, so whenever you're dividing like this, you would have to divide the whole thing. So here's your first equation in slope-intercept form. And then your second one is much simpler. You would have y equals negative x plus 5. Okay, if we look at this, you have the exact same equation, which means there's going to be an infinite number. Okay, so I'm going to put a little asterisk here. We're going to say infinite number of solutions. All right, then for number 8, we're going to also prove that graphically. So we just made an easier solution here. Oops. An easier equation here. We can just use both of these. We know that they're going to be equal to each other. That's okay. But I'm going to grab one side and I'm going to throw it into the other y. So we're going to have negative x plus 5 equals negative x plus 5. I'm going to get rid of, let's just say, doesn't really matter. They're both going to equal 0. And then we're going to have negative x equals negative x. If we were to divide both by the negatives, we would have x equals x. This is telling us that there is an infinite number of statements. Your symbol to represent that is an infinity sign. So you can get some practice there. But that would be your symbol. That infinity sign looks really bad. Do your best. There you go. So that would be your symbol to represent that. Okay. Hopefully this is making sense. Your practice. So now that we've completed our notes, you're going to spend the rest of your time working on this practice page to turn in. There is an option of getting no solutions, and there is an option for getting an infinite number of solutions. Okay, so those would be your two symbols to show that for your answer. Okay, once you have finished this, I want you to turn it in. If you don't have time to finish this, don't freak out. Tomorrow's going to be a catch-up/Mathia day. So you're going to be able to have time to finish any missing work from this week that you haven't completed, including this practice page. And then Friday, we're going to do a little bit of notes before sending you off into the weekend. I hope you guys have a great day. You can email me if you have any questions, and I will respond if and when I can. I will see you on Monday.